And we are now recording, just so you know. Section 1.1, patterns and expressions. A constant, values that do not change, numbers. You can use letters for constants. If you've done science, there are certain scientific constants. Okay, the gravitational constant 1.1, 10 to the negative 27th, I think it is, or something like that. It's a constant. We don't do that. We write G, big G for, but constants don't change. That's their constant. You can use letters for constants. Not every letter is a variable. Okay, you can use letters for constants as well. Maybe be a constant we don't know. But we don't actually call them variables. They're constants. They don't change. Variable quantity, things that can change. A variable symbol, most common one you know, X. Second most common, Y. Third, T for time. A lot of equations, a lot of functions, a lot of things are based on time, so we use T for time an awful lot. Numerical expression with numbers, no equal sign. Numbers added, subtracted, multiplied, pretty straightforward. Algebraic expression has variables involved in it. Once again, because it's an expression, no equal sign. It's not an equation, it's an expression. It's not equal to anything. 3n minus 4, I don't know what n is. There's nothing equal to, so I can't solve it. N is not negative 3/4, or not 4/3. We didn't set it equal to 0. We didn't solve it because there is no equal sign. It's an expression. Okay, everybody got this? Okay, next one. Develop a process for the number of toothpicks needed for the configuration. The idea is we want to figure out how to write an expression that describes how many toothpicks are in a figure based on how many figures we are. Okay, so the first one, we have 4 toothpicks. Read the problems carefully when you're doing these, because the other one might say tiles, which would be completely different than toothpicks. If it's tiles, I have 1 tile in the first figure. Toothpicks, I've got 4 of them. Do you see why I have 4 toothpicks in the first figure? Okay, 4 sizes. In the second one, how many do I have? I've got 8. In the third one, how many? I have 12. Okay. Now the process column, to me, this is more workspace. What I'm concerned with is, can I get a formula down here at the bottom? That's what we're looking at on this one, is I'm trying to get that formula. So if I know the 5th one, I can figure out how many toothpicks there are without having to do 5 figures. I can do the 100th one without having to do, okay, here's the first one, here's the second one, without doing the first 99. I want a formula for that. I want to know what the nth term is. How many are in the nth one? That is the formula for it. Okay? It's actually not that hard. It's fairly simple to do, particularly with the ones that we have here. How do I get from 4 to 8? What do I do to get from 4 to 8 that I can also do to get from 8 to 12? Just looking at these numbers here. I can add 4. If I add 4 and add 4, if I'm adding or subtracting the same thing each time, that is my first step in finding my formula. My formula is 4 times n plus or minus something. Plus or minus something. That plus or minus might be 0. I might not be adding anything to it. Okay, so in my process column, technically what I have here is I have 4 times 1, 4 times 2, 4 times 3, and possibly plus or minus something. Is 4 times 1 what I have here? Is 4 times 2 what I have here? 4 times 3 what I have here? Yeah, then I don't need to add anything to adjust it. So it is 4n. Technically, it's 4n plus 0, but we are lazy. We do not write plus 0, because that doesn't change anything. Okay, does that make sense? So this is our formula. That's what we're trying to get. So if I want to know the fifth term, it's 4 times 5. I want to know the 100th, it's 4 times 100. 4 times however many figures I have is how many toothpicks are in that figure. That's my formula. That's my goal. Does that make sense? Okay. A lot of mathematics is seeing patterns and figuring out something to describe that pattern. The more complicated the patterns, the more complicated the math to go with it. Okay. Same thing. Let's do this one together. Okay, so I have 1, 2, 3 figures, and I want to find the nth one. And this one, once again, is toothpicks. How many toothpicks are in the first one? 4. 5. 1, 2, 3, 4, 5. Right? Got 5 toothpicks to make that one up. Okay. How many are in the next one? How many do I have? 10. Oh, this is too easy. How many do I have in the next one? 15. Okay. Once again, I want to look for a pattern here, ignoring the figures in just the numbers. How do I get from one to the next to the next? What's the same thing? Doing the same thing, how do I get from one to the next? What am I adding or subtracting? Because I could be subtracting. What am I adding or subtracting? I'm adding 5. Plus 5, plus 5. So I have 5n. Once again, it might be 5n plus something, 5n minus something, or not at all. I go back to the process column, 5 times 1, 5 times 2, 5 times 3. Do these match those? Does 5 times 1 match 5, 5 times 2? Then I have technically, I have a plus 0. So I just have 5n as my pattern on this one. Does that make sense? Any questions so far? Start out deceptively easy. Just saying. Your turn. Do those. Okay. Same idea. 1, 2, 3 figures, and n. And this one calls for tiles, not toothpicks. Gotta read it carefully. I warned you. Same thing's going to happen on quiz and tests. You need to read the questions carefully. If you read it right, it said tiles. There are 3 tiles. Okay, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 toothpicks, I think, but it's 3 tiles is what we want. On the next one, we have 5 tiles. On the next one, we have 7 tiles. We're looking for the nth, and we actually want to do this to figure out what the 25th is. Make that look a little bit better. 5, 7. Okay, how do we get from 3 to 5 and 5 to 7? Add 2. Plus 2, plus 2. So I have 2n. Now, is 2 times 3, oh, sorry, is, yeah, add 2. So I have 2 times 1, 2 times 2, 2 times 3. Is 2 times 1, 3? Is 2 times 2, 5? No. How much? What's the difference between these and what these are? I need to add 1, right? 2 times 1 plus 1, 2 times 2 plus 1, 2 times 3 plus 1. So my formula is 2 times n plus 1. I had to make an adjustment on this one. Okay. So the 25th one is 2 times 25 plus 1, or 51. There will be 51 tiles. Okay? Questions? This is a big part of mathematics, seeing patterns and coming up with the math that describes those patterns. For us, they're really simple ones, but they can get very complicated, trust me. Okay, so I think there we go. Yep, that's it.